My name is Peter Baas. I'm working at Whiffle for quite some years now. I'm part of the research and development department, and I'm working a lot on the validation of our model. With the growing size of wind farms and wind farm clusters, it is no longer possible to consider wind farms in isolation, and this holds for many parts of the globe, for instance the North Sea, but also the US East Coast and the Baltic Sea. To get a proper estimate of the annual energy production of new projects, wake effects from upstream wind farms must be taken into account. Although some engineering wake models have the capability to include the effects of upstream wind farms, a better solution is to use a full physics-based weather model like Whiffle's LES. For instance, the length of wind farm wakes depends on the boundary layer depth and atmospheric stability, which are naturally represented in the LES. In contrast to, for instance, RANS modeling, Whiffle's LES-based weather model does include the effects of spatial heterogeneity on wind farm wake dynamics. It will pick up spatial variations in stability, microscale and mesoscale weather phenomena, and internal boundary layers that may result from land-sea transitions. All these phenomena may impact the evolution of wind farm wakes and the interaction of wakes from one wind farm to the other. Whiffle has been involved in the WINS50 research project. For that project, we studied a large-scale rollout of offshore wind energy in the North Sea with a scenario for the year 2050. The results showed that wind farm wakes are all over the place. Production deficits due to the presence of upstream wind farms is the rule rather than the exception. For example, we showed that the production of currently operational wind farms may decrease by 6 to 7%. For a particular wind farm, the exact number depends on the distance and amount of additional wind farms that were foreseen. So the WINS50 research project shows that interactions between wind farms must be taken into account, and Whiffle's LES model is the excellent tool to study this dynamics.